right, here we go. All right. So this is just some stuff from exam 3. I figured I'd go through it because I figured, I know there's some probability on the final exam. I figured also it would be a good idea to review some of this. So this was one of the questions on the third exam. You want to find the probability. Suppose you're drawing a card, one card at random from a standard deck of 52 cards. Okay, so we want to get some probabilities then. We want to find the probability that the card drawn is a face card, the probability that the card drawn is not a face card. We also want to get some odds here, like the odds in favor of drawing a face card and the odds in favor of not drawing a face card. That's what I meant to write. I don't know how I missed that. But anyway, I think it should be on, okay. Okay, that should be a not drawing a face card. Let me just fix that. Not drawing a face card. I don't know how I missed that. Anyway, with probability here, you're drawing one card at random. Remember, all the cards are equally likely. That's what we're assuming. For face cards, what's a face card? Well, Jack, Queen, and King. Okay, that's just what a face card is by definition. Now, there are 4 suits in a standard deck of cards, right? There's hearts, diamonds, spades, and clubs, right? Each suit has these 3 face cards. So altogether, there are 12 face cards. So the probability then is 12 out of 52. You don't have to round this to a decimal. I mean, you can. If you do, I'm not going to mark it wrong. But you could leave it as a fraction. You don't have to reduce it. I know on the third test, I think some people wrote it as a reduced fraction and as a percentage. I know that was in the instructions by mistake. So if you did that, I didn't take off points for that. So just letting everyone know. Now, how would you get the probability, though, that the card drawn is not a face card? Well, remember, if you know the probability of an event occurring, the probability that the event does not occur, it's 1 minus the probability the event occurs. So in other words, the probability that a card drawn is not a face card, it's 1 minus the probability that the card drawn is a face card. An event and its complement add up to 1. The probabilities add up to 1. So if you know 1, you get the other by subtracting from 1. That's really what I'm trying to say here. So you have 1 minus this, which turns out to be, just by basic fractions, 40 out of 52. That's what we get here. Okay. Now, there was also this notion of odds. The odds in favor of an event, there's different ways of finding it. One way is the probability of the event occurring, divided by the probability that the event does not occur. That's just, again, actually, it's just the definition. So in this case, it's the probability of drawing a face card divided by the probability of not drawing a face card. Okay. So that's what this is equal to. The probability of drawing a face card divided by the probability of not drawing a face card. And we actually got that already, right? It's 12 out of 52. This is actually how we got the probability of not drawing a face card, which is 1 minus. So we have this here, as you can see. And now how do you get from here to here? I think I actually presented this sometime in the course. What you can do is you basically take off these 2 denominators. Since they're the same, you could take them off. I mean, algebraically, what you're doing is this. Let me see if I can, well, it's not really much room to write it in, but that's all right. But basically, this is what you get. These denominators actually cancel, and you're left with 12 over 40. You really don't want to write this as a fraction, though. You want to write it like this, with a colon, 12 to 40. And then what would the odds be in favor of not drawing a face card? It actually turns out to be just the odds in favor, but you invert it. I mean, you could go through this calculation again, but it just turns out to be 40 to 12. So these are the odds in favor of not drawing a face card. So these are the odds in favor of drawing a face card. These are the odds in favor of not drawing a face card. Basically, you just invert. You know, how do I say this? You turn it, I hate to say, I don't want to say upside down, but you just interchange 40 and 12. But you could go through this calculation if you want. All right, any questions on that? All right, so again, you just basically, you invert, in other words. You know, you interchange, you turn it upside down, so to say. But then you have to write it as a colon like this. All right, this was another one dealing with a poker hand, okay? A poker hand has 5 cards, and you're randomly, you know, dealing from a standard deck of 52 cards, okay? Now, the order doesn't matter, I tell you that, but keep in mind also, you're actually doing this without replacement, okay? It's without replacement. In other words, when you're dealt those 5 cards, you know, you don't get a card, look at it, and then it goes back in the deck. You hold on to the card, then another card is handed out to you, then another card after that, and so on. Okay? So in other words, the order doesn't matter. It doesn't matter what order you have the cards in front of you, and it's without replacement. Okay, that's good. So we're going to determine these probabilities. What's the probability that all 5 of the cards here are hearts? Okay. Well, so the other ones here we'll get to as well. You know, getting exactly 1 jack, exactly 2 jacks, then exactly 2 aces and 3 kings. All right. So again, order doesn't matter. And as I said already, the cards are selected without replacement. That tells you want to use combinations. Okay? Combinations. In other words, you're going to use combinations. So since we're finding probability, well, we want to know how many ways we can get 5 cards, right, handed out to us. Order doesn't matter, and selected without replacement. That's what this CF525 is. It's kind of like our sample space, basically. You know, of all the possible 5 card hands you can get, right, you want to know how likely is it that you're going to get all hearts. Okay, that's what we want to know. Okay, so from here, this is what we have. We have C of 52, 5. That's our sample size. In other words, that's how many possible 5 cards, that's how many possible ways 5 cards can be handed to us from a standard deck of 52 cards. Okay, so that's what we get here. We have 52 factorial divided by 5 factorial. C of 52.5 is 52 factorial divided by 5 factorial times 52 minus 5 factorial. If you did this in Desmos, this is what you would get. You don't actually have to do the factorial stuff. I mean, you can, but you definitely have to do this and the answer. Okay, that's good. All right. Now, there are also 13 hearts in the deck, right? We want to know how many ways we can get 5 of those hearts. In other words, we want to know how many ways we can get 5 hearts from the deck without caring about the order and without replacement. That's what this is, combinations. You know, you have CF13, that's how many hearts there are in the deck. You only want 5, and that's what we get here. And this is probability. You have to divide the number of outcomes that we care about, which in this case is the number of ways we can get 5 cards that are all hearts, divided by the total number of possible outcomes. So this is what we get here. Okay, so again, C of 52.5, that's how many possible ways we can get 5 cards from a standard deck of 52 cards, you know, in a poker hand, that is, and we don't care about order, and it's without replacement. C of 13.5 is how many ways those 5 cards could be all hearts. Let me show you how to do this in Desmos. I mean, you can do factorials, but that's really more work than necessary. At least with me, the way I'm grading it. So let me get the Desmos to show you. If you go to the scientific calculator, they have those functions in there. Wait, let me share the screen because they can't see it. All right. Just let it come here. Here we go. Here we go. So here we have our scientific calculator. I'm in Desmos here, right? Go to our scientific calculator. And you want to get those combination functions. You go to FUNC, which is function. And you can see NCR right here. Okay? So that's what we get. So we have 52, comma 5. It's N. The N is the first number, right? That's how many possible. That's how many. No, excuse me. The N is first, and then the R is afterwards. Okay. N is how many total items you can choose from. R is how many you're actually choosing, right? So there are 5 cards from a deck of 52. N would be 52. R would be 5, and that's how we get it. Right? The N is first, and the R is second. Okay, N is how many items you're choosing from, right? We're choosing 5 from 52 cards, or 5 out of 52 cards. R is how many of those items you're choosing, which is R. All right. And if you did CF13, and if you do here, 13, comma 5, right? You get 1,287. So the scientific calculator, Desmos, that is, you can use, which is really nice. So, all right, let me stop sharing this. Hope that makes sense. Okay.